Today's lecture is about calculating the current in a single loop circuit while taking into account the internal resistance of the seat of EMF, which in this figure is represented by small r. But before doing that, we will quickly go through the lecture which I delivered yesterday, and that was about calculating the current in a single loop circuit. As you can see in figure 1, this is a single loop circuit which consists of a seed of EMF E, and then there is a resistor R connected across the terminals of this seed of EMF. Now, what happens inside the seed of EMF? The seed of EMF does work on positive charge in carrying it from negative terminal to the positive terminal, and then outside these source of EMF, that is in the external circuit, what happens that this charge moves in the external circuit, and while it comes to the terminal of the resistor, it will enter the resistor from the positive terminal and it will leave it at the negative terminal. That is, if you traverse this resistor in this direction, which is the direction of the current, you are going from a point of higher potential to the point of lower potential, and in doing so there will be a drop of potential, or in other words, there will be loss of the electrical potential energy, because we are moving from higher potential point to a point of lower potential. So there is a loss of potential energy, which is in fact the electric potential energy, and that loss will be given by I square R dt. Now if we apply the law of conservation of energy, then the electric potential energy which was gained here, why it was gained? Because we were moving from the lower potential to the higher potential, and the change in potential was positive, and hence there was a gain in electric potential energy, which was equal to the work done, and that was given by EIdt, because the EMF E is the work done in carrying the charge dq from this negative terminal to the positive terminal, and this gives us the work done dW equal to the product of E and dq. And if we represent dq in terms of I dt, then this dW will be equal to EIdt. This is the electric potential energy which was gained in moving from negative to the positive terminal. So this much electric potential energy was gained, and then the same amount of electric potential energy will be lost when we move across the resistor from the upper end to the lower end, or from a point of high potential to a lower potential, and the amount of electrical energy lost will be given by GW is equal to I square R dt, and these two equations, the left hand sides of these two equations is equal to dW, so we can equate the right hand sides, and we will get EIdt equal to I square R dt. Now Idt on both sides will get cancelled, and we will get E is equal to I times R, and then I will be equal to E divided by R. Now this is the current in the single loop circuit, which is given in this figure.